Welcome to Trinad chemistry classes. In this video, I am going to discuss about intermediate first year chemistry topic acids bases. In this acids bases concept, I am going to discuss about solubility equilibria and sparingly soluble salt. Solubility equilibria and sparingly soluble salts. So we know the word the solubility. Solubility of ionic solids. Solubility of ionic solids in water. Solubility of ionic solids in water varies a great deal. A great deal. Varies a great deal. That is, some of the salts, some of the salts are highly soluble. Highly soluble. Some of the salts are highly soluble. For example, if you take salts like calcium chloride, they are highly soluble. They are highly soluble. That is, some of them are also simply hygroscopic in nature, and some of the salts have a ability to absorb the water vapor from atmosphere. Water vapor from atmosphere. Whereas in other case, if you take salts like lithium fluoride, salts like lithium fluoride, their solubility is very less. Solubility is very less. Now, the solubility of a ionic solid in water, the solubility of ionic solids in water, the solubility of ionic solids in water depends on solubility depends on number of factors. Solubility of ionic solids in water depends on number of factors. Among them, the two important factors are, one is lattice enthalpy, and second one is hydration or solvation enthalpy. One is lattice enthalpy and another one is solvation enthalpy. So the important factors which affect the solubility of an ionic solid, solubility of ionic solid in water is, one is lattice enthalpy, one is lattice enthalpy of the salt, and the second one is solvation enthalpy of the ions in a solution. Solvation enthalpy of ions in a solution. So now, what is lattice enthalpy? Lattice enthalpy is the attractions between the, for example, if you take lithium fluoride, so Li plus and F minus ions. So lattice enthalpy is the amount of energy required to break the intermolecular attraction forces between the Li plus ions and F minus ions. Those ones we are calling it as the lattice enthalpy, right? So the attractions between the electrostatic attraction between the positive ion and negative ion, that one in a ionic solid we are calling it as the lattice enthalpy, and the second one is ionic solvation enthalpy. So when dissolved in water, the ions are dissociating and liberating energy. That enthalpy we are calling it as the solvation enthalpy. That enthalpy we are calling it as the solvation enthalpy, right? So in the solvation enthalpy of ions, in terms of solvation, which is always negative, that is solvation enthalpy is always exothermic. This is always exothermic. For this delta H is always negative, whereas lattice enthalpy is always positive. So now, solubility of a solid depends upon lattice enthalpy and solvation enthalpy. If lattice enthalpy is more than that of the solvation enthalpy, the solubility of a particular solid, ionic solid in water is very less. If lattice enthalpy is greater than solvation enthalpy, the solubility of that ionic solid is less. If lattice enthalpy is less than solvation enthalpy, solubility of the ionic solid in a solvent is more. right? So lattice enthalpy, solvation enthalpy. So lattice lattice enthalpy is defined as the energy that must be supplied to 1 mole of an ionic solid in order to separate it into gaseous ions. That one we are calling it as the lattice enthalpy. So if lattice enthalpy is strong greater than that of solvation enthalpy, the solubility of that solid in a water is very very less. If lattice enthalpy is less than solvation enthalpy, solubility of that solid in water is very very high, very very high. So based on the solubility, based on the solubility, based on the solubility of a substance, solubility of a substance, salts are classified into salts are classified into three types. One is soluble salts. So whose solubility is greater than 0.1 mole. Whose solubility is greater than 0.1 mole. If solubility is between less than 0.1 mole, those are called slightly soluble salts. Slightly soluble salts. And there is another one. If the solubility is very very less than 0.01, those are called sparingly soluble salts. Sparingly soluble salts, right? Based on the solubility. So solubility of an ionic solid depends upon, one is lattice enthalpy and another one is solvation enthalpy. If solvation enthalpy is more than that of lattice enthalpy, those salts are highly soluble. If solvation enthalpy is less than that of ionic lattice enthalpy, those salts are slightly soluble. Based on the solubility, salts are classified into two types, so three types. One is soluble salts, slightly soluble salts, and third one is sparingly soluble salts. So soluble salts means their solubility is greater than 0.1. If solubility is between 0.1 to 0.01, between 0.1 to 0.01, those are called slightly soluble salts. If solubility is far less than 0.01, those are called sparingly soluble salts. In case of sparingly soluble salts, there exists an equilibrium between the dissociated form and associated form. So I have assumed a sparingly soluble salt AB, which exists as A plus and B minus ion. So when this sparingly soluble salt is dissolved in water, there exists an equilibrium between the dissociated form and undissociated form, right? So some of the salts will be remain as a solid. That's why there exists an equilibrium between the dissociated form and undissociated form. Thank you for watching Trinath chemistry classes. Please like the video, share and subscribe the channel.